I was tasked with integrating a third-party library into a project. But then I noticed something. The project had just rolled out a new version, and to my surprise, the API object was completely different from the old one. This was a major problem because it means that the new and old API versions are no longer compatible, and this resulted in a breaking change in the project. I wanted to focus on the first method in the API integration class. This method, which is the process API method, takes an API object with a type of object as the parameter. The use of object as a parameter often denotes an unknown type. This is where reflection comes in. Reflection frequently uses object as a placeholder for unknown types. For example, in the first try block you can see on the code, I used reflection to call the execute method, which is inside the API object instance. Most times, this may require casting and can skip type safety checks, leading to the risk of having runtime errors. And you may ask, what are runtime errors? Well, runtime errors in Java are mistakes in your code that don't show up when you compile your program, but occur when the program is running, usually in production or during tests. So when I wrote the code for the first time, it felt like a clever workaround until my code was reviewed by a senior software engineer, and then I realized the problem. My fix was just like a landmine. It was like a ticking time bomb, and it was only a matter of time the application could crash in production because I had written a solution that could fail silently until it was too late. Now, I can hear you asking vigorously, what's the problem here? And I still don't get it why reflection is bad. I hear you clearly, but hey, if you're meeting me for the first time, my name is Courage, and I work as a software engineer. Every day in my coding journey, I tackle new challenges and I write them down in my notebook. I love turning those experiences into valuable content. Here, I break down the hurdles I face and share the solutions I discover along the way. So, the problem here is the use of reflection. Now, imagine you have a remote controlled toy car. Normally, you can only use the buttons on the remote to make it go forward, backward, left, or right. But you see, with reflection, it's like you have a special remote that lets you open the car and see all the parts inside. You could even change one of the parts in the car to something else while the car is still moving. You can even go further to make the car do things it wasn't originally designed to do, like honk a horn if it didn't have one before. So, reflection is powerful. It's like a magic wand. It lets you tweak code at runtime, but it's risky. The reason is because it skips type safety checks. So this means that the compiler that compiles the code cannot check if your code or the method names or parameters are correct before the application runs. So imagine building a toy car but only finding out the wheels doesn't even fit when you race it. That's basically disaster. Those runtime errors can crash your application in production and are super hard to debug. On the other hand, writing type-safe code lets you avoid runtime errors. It's like testing the car in the workshop before the car is taken out for a drive or for racing. Avoiding reflection in your code makes it clean, safe, and saves you from lots of production nightmares. Reflection slows down your application and drags down the performance of your application in production. It also makes code super hard to read and to maintain. You should try to avoid reflection as much as possible because it's a risk you don't need to take. So, how did I fix or solve this issue? I took a fresh look at the library's documentation, and after some thorough exploration, I discovered that the particular method which I needed in both the new and old APIs actually implemented a common interface. That was my lightbulb moment. I refactored the method to utilize this interface, eliminating the need for reflection entirely. Now, back to the example I showed earlier. The process API method now takes the processor object with a specific type called processor in capital P. So it turned out that both the old and new APIs implemented this processor interface, which enabled me to call the process method on the processor object directly without using any reflection. The result of this is a cleaner and more type-safe code with errors now being caught at compile time. It's like upgrading from a shaky bridge into a solid highway. Here's the takeaway. When you are tempted to use reflection, please pause. Look for a type-safe solution. Maybe you can look for a common interface like I did, or use polymorphism. Have you ever faced a situation like this in your own projects? Please drop a comment in the comment section. I would love to hear how you resolved it. And if you found this video helpful, please hit the like button and subscribe for more contents like this. Thanks for watching and see you in the next one. Bye.